Black hole created on lab? No! I'm not kidding. Scientists actually have done the unthinkable by creating a black hole in a lab. An article published recently claims that scientists have successfully created a quantum black hole right here on Earth. Yes, you heard that right. And here's the amazing part. This tiny quantum black hole acts a lot similar, like the massive black holes we have seen in the space. The one captured in those incredible pictures shared by NASA and other space agencies. But how did they do it? And what does this mean for the future of science? Watch the full video to discover the fascinating, groundbreaking work scientists have actually done. Let's dive in. So, black holes are some of the most mysterious things in the universe. They're regions in space where gravity is so strong that nothing, not even light, can escape. It's like a cosmic trap that swallows everything that gets too close. Normally, black holes are found far away in space, millions or even billions of light years from us. They form when massive stars collapse under their own gravity. But here's the big question. How could scientists possibly create something this powerful in a controlled environment, right here on Earth? Let's break it down and find out. How it was created. Scientists wanted to explore black holes in a lab, something that seems impossible at first. But they found a clever way to mimic black hole-like behavior, using ultra-cold atoms or simulations with light and sound waves. For example, they used ultra-cold atoms to create something called a Bose-Einstein condensate. This is a super-chilled state of matter, where atoms behave almost like one single giant atom. By manipulating this condensate, researchers can replicate conditions similar to a black hole's event horizon, the boundary where nothing, not even light, can escape. Another method involves using intense lasers or electromagnetic fields to create a kind of event horizon for light or sound waves. This doesn't form a real black hole, of course, but it acts like one in key ways, making it possible to study its properties. But what was the purpose of this experiment? The big idea here is to study something called Hawking radiation. In the 1970s, Stephen Hawking proposed that black holes aren't completely black. They emit a tiny amount of radiation, which could eventually cause them to disappear. This radiation has never been observed in space because it's so faint. By creating black hole-like conditions in the lab, scientists hope to detect a similar kind of radiation. If they succeed, it could confirm Hawking's theory and teach us more about the connection between quantum mechanics, the physics of the very small, and general relativity, the physics of the very large. In simpler terms, this experiment helps us understand the rules of the universe on a deeper level, like how the tiniest particles behave around the most massive objects. And who knows? These insights might even lead to new discoveries about the cosmos. This experiment helps us dive into the mysteries of the universe without needing to travel through space. By simulating black hole behaviors, scientists could unlock breakthroughs in quantum physics, gravity, and even how the early universe formed. But there are some limits. These lab-created black holes aren't the same as cosmic black holes. They replicate specific properties, not massive gravitational forces, which is why it is not as dangerous as black hole in space. So, while these lab experiments aren't real black holes, they could unlock the universe's deepest secrets. Is this the beginning of a new era in physics, or just the tip of the iceberg? What do you think? Let us know in the comments.